So our next speaker is going to be Nasron Cheong. Nasron Cheong. He is from a company called IntegrateFL. And so he is the third company that we're going to hear from today that is building on top of Flower to build a company. So with that, Nasron, we're happy to hear from you.
Sure. So hi, welcome everyone. Thanks for listening to what I've got today. So I work at a company called Integrate AI. We have a product called IntegrateFL. I'm the principal software engineer, architect there. And so I kind of oversee engineering and everything else that we're doing. So kind of a quick overview of what Integrate AI is. We're a 5-year-old startup in Toronto, about 40 people in size. We've got a bunch of awards and first company to be Privacy by Design certified. We've worked in different techniques for privacy safe ML, and now we focus on federated learning. It's one of the core of the product that we'll be talking through today. So just as many of you have already seen throughout our conference here today, there's like data silo use cases and there's kind of the edge mobile silo use cases. The IntegrateFL product is geared towards the silo use cases, and it's for cases where data cannot move, cannot be centralized due to regulatory or other reasons. And as you've heard a lot again today, it's about healthcare, right? Healthcare is a thing that comes up a lot. You have models that you want to predict outcomes for. There's not enough data. It's unbalanced. Cancer outcome prediction is a common one. We've seen that already twice today. And so what you need is a toolkit for those that want to federate models with FL frameworks like Flower, which is what we're talking about today. But let's say you do want to use something like Flower, but you don't want to invest the time in the infrastructure needed to support Flower. A little note is that we're not focused on the mobile federated learning for now. So the issues are faced when using Flower. I mean, Flower is a fantastic library for FL, which is why we base IntegrateFL on it. It provides like the core networking protocol and the framework to make extend strategies. So you can add new strategies, you can do it handles the communication details between clients and servers. What we added in our product is FL as a service. The central aggregation server is managed as a per FL session basis. So there'll be a little bit of a kind of an offline demo I'll go through, and I'll show all these little parts in this demo. We've added differential privacy at the data participation level, which means that we add the privacy at the client level. So the model is fuzzed out before the model weights are sent to the central server. We've added authentication, so there's like user management in terms of who can start sessions, who cannot start sessions, what sessions participate with each other. Session management, which is about a history of your sessions. And related to that is model management. How do you store your models? Who stores it where? And we have that API-driven interaction of how you actually work with the system. So it'll be very familiar to people who've already used Flower. So just to, oops, let me go back here. Right, so like for training, so we'll just do like a kind of a quick, kind of dry, not really online version of IntegrateFL so we can to save some time. I'm going to show how FL sessions are created in the API, how to monitor results in the UI. So here, what we've got is, so this is a Jupyter notebook with the SDK installed. And so what we have here is the IntegrateFL SDK that you can install, you get connect. And here you're making a connection to our service. So you provide your username, your password, and a customer code. And the customer code represents your specific spin up. So when we spin up one of these things for a particular client, we spin up an entire stack at single tenant, which means you kind of get your own version of all the resources in the background. So the first part you want to do is get your model configured. So the configuration for built-in models, we actually have kind of two ways of getting models to be federated in our system. One is to use built-in models that we've already designed. So this is kind of a low-code approach of getting a model going. And so right now there's an FFnet and a GLM model that's available for this built-in model approach. And here you have a configuration that shows, you name your experiment, your description, you name the strategy. So we can have multiple strategies. Over time, we'll add more. You can specify your model. These are the FFnet kind of neural network parameter models. A few other things here, and the differential privacy, which we can talk about epsilon, which is here, which we've heard from Micah before. It is a difficult value to set, but we have it, and it can be used to fuzz out the models. And we also say specify a data schema, which helps the system describe and kind of validate the data that you're actually going to send to the system. So this is one approach where you can use built-in models that we provide. And another approach is to upload a custom model. So in this situation, you can run a command where you can take our SDK, and if we look at all our documentation here, you can see that you can create a custom model that allows you much more granular control over the model that you want to actually do. So the interface is similar to Flower, but it's not a direct interface to Flower. So it's a little bit different because we also handle the differential privacy at this level. So you can create a custom model, but still have the differential privacy attached to it. So you can create a model, you kind of make a couple of files, create a dataset file, and then you can upload it, and this sends it to us, and you can give it a name. And so now we hold the model class, and we can distribute it to the FL client sessions when they need to be started. The next step is to create a session, and creating a session is as simple as taking the client, calling create session, giving it a name, description, how many clients you want, how many number of rounds you want, the package name, which is either the model name. So if it's a built-in model, you can give it an FFnet, or my custom model name, which is the same as this. And this will, once you start this, will start a central server on our side. And you get a session ID. And the next part is to actually do the training. So the training requires that you pull a client Docker that we've provided. So this is a prepared Docker that has a client already installed, like already pre-configured. The Docker image has a GPU available. So you can run it on a GPU instance so that it takes advantage of GPU, all that kind of stuff is handled. Once you have this container spun up, you can run the training command. And so at this point, the training command looks like this. And what we're doing here is that we take HFL train, we can give it a session token. A session token is the same as right up here. And sorry, the session token, sorry, my mistake. The token here is the security token, so that to authenticate this client to us, so that we know that you're authenticated to actually connect to us. A session ID, which is the session that was started right here. And a train path to some data that's been mounted into the Docker container. And so once this starts, it'll actually start training. And while it's training, here you can poll for session status, where you poll our service to determine when the session training is complete. And so once that's all done, so while this is running, you can view, you can access all the metrics, and sorry, not metrics, but like the progress things in here. Or you can go to our UI. So if you go to our UI, you can look at sessions. So these are like previously trained sessions that we've done. You can look at a session. And here's a completed session, which shows you what happened during the round, who did it. This is a client ID. This is the examples, accuracy, and which are all kind of configurable. And gives you kind of the status of the session, what data configuration is, what the model configuration is. All this stuff is kind of handled by us. So once you have the training complete, you can take a session, get the metrics, and print it out as a dictionary. And this would print out the actual metrics that were collected for the actual training session. Then you can pull the model and get it as a PyTorch model and do the inference. So what this actually does is that downloads the model for the session for you. So what we've actually done here is taking care of all kind of the management of what is happening with the FL session. So you can kind of compare your sessions and access it through the API and do all those kinds of things without having to actually set up any infrastructure, because all of that is handled. So if we go back to kind of what's next, we could go over a high-level architecture of how IntegrateFL works. So there's a UI service and API service which authenticates the user. So there's kind of two blocks here. This is everything that's is Integrate AI, and this is the customer environment. And the customer environment is who's the user. So you would pull our Docker image from us in order to kind of get data into the system, and it would connect to our FL service, and the API also connects to the FL service. And again, everything's single tenant, you get a separate stack. And this FL server here that's spun up, every time you spin up a session, it spins up an FL server. And this is a Flower server, effectively. And the client is running in this Docker image over here. So we can talk a bit about the changes that we had to do. Like, what do we have to do to change in Flower to get IntegrateFL to work the way we wanted it to work? One of the main goals is to have a fairly simple networking for clients in the theme of kind of minimizing the setup work for an FL system. So if we kind of go back to this architecture diagram, you can see that both your API and the clients, everything goes through this FL server, which means the weights that are being shared to the FL server from the client for the rounds are actually being pushed through a API server here. So this gives the advantage that it's very simple for networking, right? You only need to open an egress HTTPS port to our Integrate API service. And the way we achieve this is that we overrode the transport mechanism. So instead of gRPC, we basically rewrote the transport layer inside Flower and then still use the proto-op mechanism because that's the stuff we actually really liked out of Flower. We might go back to gRPC in the future iteration, especially if we want to provide the ability for customers to run their own FL servers instead of us running them. Because sometimes some of our clients have mentioned that that's something that's interesting. Another part is the transport mechanism uses JWT authentication. I mean, technically gRPC can too, but we've also ensured that we've done it in our system and that only specific clients can connect to the service. We also have VFL facilities like secret exchange sharing, private set intersection. They're there, but we don't have it actually part of the current version, mainly because they're complex. And we wanted to focus on HFL, horizontal federated learning, before we moved into the VFL space until we know of a good use case to actually apply. We also have model management. So we added the model management to Flower. So when Flower finishes training, the FL server actually saves the model in a way that is accessible to us. So our roadmap is what's next for us is EDA. That's a big one for us. It's like how do you do EDA and statistics on data if you can't access it because it's private, right? So we are probably going to add a whole bunch of functionality to give us kind of the federated analytics that are needed in order to do an FL system without actually having to access the data directly, and so that we have a good kind of DX workflow as time goes on. We're going to add decision tree based models, so random forest gradient boosted trees into FL. So that's something that's happening pretty soon. And under consideration is kind of agents, right? We want to be able to eventually have systems where you install something at a client site and it spins up as needed in order to do the training that's driven by a customer instead of currently the API forces you to actually have to go and spin up the clients yourselves. And then secure multi-party computation or secure aggregation are things that we're planning on adding, and a deployable FL server. So you can have a semi-SaaS system where we manage all the stuff, but we'll deploy the server in your environment and possibly go back to gRPC in that process. And we're looking for partners. So at this stage, we're looking for partners to work with to find great use cases to actually use our product. So we have a few good partners in the pipeline now. If you're interested, please definitely talk to me. And we're hiring. So like if you're interested in working in this space, definitely get in touch with me as well. This is a quick thing. I'm not going to go through it. You can take a look at this once you access the slides. It's just to give a good idea of like how you can, how to apply like use cases to our product. And that's it. So if there's any questions, I'm open to it.
Thanks so much for the great talk. Let's see, questions we have. From the online audience, we have this question. How can you choose the best epsilon for DP for all data sets? Is it possible to have various epsilons based on the sensitivity of each data set?
That's a good question. Unfortunately, right now, like it's an open configuration. It's just the epsilon parameter. It's kind of up to you to decide what the epsilon parameter means. But right now, it is just kind of distributed to all the clients. But that's a good question. I wonder why we didn't do it per client. I'll bring it up with the team.
Okay, that's cool. Next question we have is, what kind of customers are using IntegrateFL so far?
So right now, one of our partners is kind of working with, is in the kind of the genomic space doing some of this work, trying to integrate, like having us kind of handle all the FL stuff so they don't have to handle it. And then they are handling the kind of the data management and all the kind of governance stuff in order to train models in the use case. So that's pretty early on, but that's what's happening. As well as there's a couple other partners working in kind of marketing spaces where data is in regions where you can't really access. Again, you don't want to kind of take on the burden of actually figuring out a Flower and integrate it into your system. You could just kind of take us as a service and then integrate it.
One other question. Did you try out other frameworks before you settled on Flower, or was it a bit random, or what was that journey like?
Yeah, we tried a lot of different things. So we looked into like, what were the other ones? We looked into PySift, Fate, ML, Open. Did we look at OpenFL? I'm not so sure. But I think the main reason we picked Flower was the flexibility. We need we need enough things that Flower provides to get you started in FL, but not so much framework that we can't customize it to do what we want to do. So for instance, like we've added lots of stuff, like there's all this VFL stuff that I know I haven't showed here today, but that required something flexible enough like Flower in order to do.
I see, great. I mean, I could listen to this all day long, but we have to move on. Thank you again for the great talk. It's really exciting what you're doing over there. So great stuff.